Hello everyone. So welcome to another lecture of this amine chapter. Now in our last class we have completed the chemical reaction of amines, right? So now we'll be doing diazonium salt. That's the last part of this chapter. After that one more topic will be left. It's basicity of amines. Okay, so today's topic is based on diazonium salt. So diazonium salt is of two types, aliphatic and another one is aromatic. So aliphatic is RN2X and aromatic is benzene ring, then N2X. That's diazonium salt. So the most common diazonium salt we have studied is this benzene diazonium salt. Okay, this is what benzene diazonium chloride. Yes, so as usual, very simple thing. If this is aromatic, right, because N2Cl part is directly connected to benzene ring, right? Then what about aliphatic? Let's take any alkyl, CH3 CH2 then N2Cl. so this is aliphatic diazonium salt. Name not necessary here. I'm just trying to explain you that what is aromatic diazonium salt and which one is aliphatic diazonium salt. They don't ask IUPAC naming for diazonium salt. Now here one important note point. If it's let's say this CH3 CH2 N2Cl, right? So you can also rewrite this in this way: CH3 CH2 N triple bond N and then Cl. So on nitrogen there will be positive sign and fluorine there will be negative sign. Okay, this is another way of representing. It's nothing like very important or something like that. If they give you, just assume, if they give you in this form like N plus triple bond N, assume it like this. That's it. Similarly, if I write this one N2Cl and benzene ring, you can also write it in this way. That is N triple bond N Cl. So positive charge on the first nitrogen, Cl negative charge, and something like that. Just the other way of representing diazonium salt. Now we'll discuss about preparation of diazonium salt. So this preparation of diazonium salt we already did in distinction reaction. Remember that nitrous test we did, that one. Okay, now when primary amine is converted to diazonium salt, this process is called diazotization. Okay, this process is called what? Diazotization. So let's remember that they ask this question. Okay, what do you mean by diazotization? Now let us first do preparation of aliphatic diazonium salt. Okay, that's the first one. So here let's take any primary amine, aliphatic amine. Okay, this is 1 degree, right? And let's say it's reacting with nitrous acid. So always remember, in this case the reagent is nitrous acid already did this, okay, and its formula is NaNO2 plus HCl. This is one way, or in its place we can just write HNO2, right? So let's say I've given the reagent, I'm using the reagent HNO2. So what will happen? This NH2 part, it will change to RN2Cl. So I will always suggest you to write it in this condensed form, not that expanded one like N plus triple bond NCl. Okay, no use. That is only for you to understand. Suppose if I give some example, CH3 CH2 NH2, let's say any one of the reagent is used. Let's say they are using NaNO2 and HCl, then everything will be same. This NH2 part, it will change to N2Cl. Okay, now this compound is found to be highly unstable. We already discussed that. And the moment it mixes with water, okay, so it will give you alcohol. So CH3 CH2 OH. Now basically everything is happening to this spot, to this NH2 spot. First this spot, it changed to N2Cl. The other stuff is same, okay, the alkyl part, and then that N2Cl is changing to OH. Alright. Clear? Okay, now let's talk about aliphatic aromatic diazoxide salt. This is also same, aromatic diazonium salt. Now in this case, aromatic primary amine will be used. There is NH2 and then this one. How do you know that this is aromatic? Aromatic because benzene ring is connected to functional group. Yes. And why it is primary? Because it has two hydrogen with nitrogen. So aromatic 1 degree amine, and also called primary amine. So the moment it reacted with, let's say I am using the other form of reagent, you can use HNO2 also, no problem. So here it will change to N2Cl. Okay. They usually use temperature 0 to 5 degrees centigrade. So this is benzene diazonium salt or benzene diazonium chloride. Okay, now this is also unstable. It's not that this aromatic diazonium salt is very stable, but comparative to aliphatic diazonium salt, aromatic diazonium salt is more stable. Alright, and it can stay stable for some time, and ultimately after some time this aromatic diazonium salt also becomes unstable. Okay. Now here one important note point is they ask question on that, like stability. Based on this stability, I know that aromatic diazonium salt is more stable than aliphatic diazonium salt. Right? This is aromatic and this one is aliphatic, and they will ask reason for that. Now what is the reason behind that? Reason is, you know that if I expand this N2Cl structure, so it will be something like this, yes or no? So this is aromatic part, and this one is, let's take any example, CH3. In place of R I am using CH3CH2 N triple bond NCl. So there is positive charge. Okay, now here this positive charge, no need to show the arrow that I am showing now, but this positive charge will be distributed in the benzene ring, not distributed, dispersed in the benzene ring, okay, due to resonance. So the reason for that is the positive charge on nitrogen atom is dispersed in benzene ring because of resonance. Now here, because of the presence of this C6H5, it can show resonance easily, okay, got it or not? So that's why this positive charge is equally dispersed in the benzene ring. You just have to write that statement. But here, since benzene ring is not there and suitable condition for resonance is not there, so the positive charge on nitrogen atom is not dispersed due to the absence of benzene ring. That's why this is less stable, and comparatively aromatic diazenyl salt is more stable. Now what is resonance and this stuff, they will not be asking questions, I will not explain this one, okay. I hope it's clear, right? They will ask question on this, that why aromatic diazenyl salt is more stable, something like that, okay. So you have to write this reason. If they ask in terms of aromatic, you write this reason. If they ask in terms of aliphatic, you write this side reason. Now we'll do chemical reaction of diazenyl salt. So in chemical reaction of diazenyl salt, I think there will be around 9 or 10 reaction. Out of that, half of them we already did in haloalkane haloarine chapter. Okay, so this is chemical reaction of diazenyl salt. Just wait. So in chemical reaction of diazenyl salt, mainly they ask like, since you know that aliphatic diazenyl salt is unstable, so it will not go any chemical reaction, okay, or even if it goes, it's not there in our board syllabus. So we'll mainly focus on aromatic diazenyl salt chemical reactions, okay. So the first one is if it reacts with N2Cl. I will not be writing the expanded one, but they might give you in expanded form also. So Cu2Cl2 and HCl, let's say this is the reagent. So here you will get, you just have to remember that what halogen they are using, okay. They are using this Cl or not, yes or no. So you just have to replace this whole N2Cl with Cl, something like this, okay. And some byproducts will be formed here, but we will not write that. But among all byproduct, one important thing is that they might ask one question like which gas is evolved. Always remember that in chemical reaction of diazenyl salt, among byproduct, one gas will be there which is very common, okay. It will be there in all the chemical reaction of benzene diazenyl salt, that is nitrogen gas. You have to remember that, okay. They might ask MCQ based question on that. Second one is that, let's say if N2Cl is reacting with Cu2 Br2 and H, where you can write it as option A and you can also write it as option B over arrow, same thing. So what's the halogen here we use? Br, right? So I'll remove N2Cl and this will be my Br. Third one is if N2Cl is reacting with CuCN and KCN. So here this Cn part, right, this Cn will replace this N2Cl, so here it will be NCN. Got it? Basically here in first case we use Cl, in second case we use that Br part, in third case after Cu the part that is there is Cn, right? So we'll be using that one. So this 3 reaction is called Sandmeyer's reaction. It's called what? Sandmeyer's reaction. Just wait. This 3 reaction is called what? Sandmeyer's reaction. Okay. Now the fourth one is N2Cl is there, and then it will react with Ki. So what's the halogen I have used here? Iodine or not? So that iodine will replace this whole N2Cl. Of course some byproduct will be there, and in that byproduct nitrogen gas will be there. Now if let's say that N2Cl is reacting with Cu and HCl. So what halogen I am using here? If you look carefully here, Cl is the halogen or not? Right? Cl is the halogen. Yes or no? This one. So this Cl will replace this N2Cl part. Next is if N2Cl is reacting with CuHBr. So what halogen you are using? Br, right? So that whole N2 part will be replaced by this Br. Now this two reaction is called Gaterman reaction. This reaction is Gaterman reaction. Now till here the next one we did in haloalkane halogen chapter. Okay, so let's say N2Cl is reacting with HbF4. Okay, so it will give you N2BF4. Alright, then if you heat this, then you just get F here. Okay, of course byproduct will be there, but not that important. Now till here we did in haloalkane halogen chapter. This one is called Bals-Simon reaction. Spelling might be wrong, you can check it, okay, from book. So Bals-Simon reaction. Now the next one that we will do, from here onwards new chemical reactions you have to study. So it will be around 4 chemical reactions. So let's say it's reacting with HbF4. okay, so here will be N2BF4, and then let's say it's reacting with NaNO2, then copper is there and heat is there, right? So this NO2 part, can you see this one will replace the whole stuff. So NO2, and this will be your answer, final product. So let's say you have this N2Cl and it's reacting with CH3CH2OH. What is the name of this one? Like extra information, ethanol. So instead of giving this structure, they might give you the name ethanol. So it will change to only benzene ring. Okay, it's a very important one. This one and the next one, they keep on asking this chemical reaction. They have asked many times in previous year question. So let's say there is N2Cl and it's reacting with H3PO2 and H2O. This one is also important. Okay, here also you will get one benzene ring. And last one is, let's say N2Cl, it's reacting with water. Okay, so OH will replace this N2Cl part. Got it? So with this we are done with the chemical reaction of benzene diazonium salt. Okay, you have to memorize this, and the reactions are easy, but the last three reactions, the new one is important. Okay. Now another set of reaction that comes from that they ask from benzene diazonium salt is called coupling reaction. Just wait. So in coupling reaction, you have to remember one structure. This structure, okay. This one is called azobenzene structure. And this spot, just because we'll be using this spot, so that's why I'm telling you, especially these two spot, they are called para spots. Okay, para position, you know that ortho meta para, right? So this is para position, you have to remember that. We'll be using this spot. Now basically in coupling reaction, dyes are made. Okay, dyes, it is mainly used to make colored dyes. You know the dyes that we use in color, that we use in clothes to give different color. So you have to remember that it gives you two color, one is orange and another one is yellow. So here what will happen, this benzene diazonium salt, okay, let me directly give you the chemical reaction, okay, and then I will explain it what is actually happening here. So let's say N2Cl is reacting with let's say it's reacting with phenol. Okay, is reacting with phenol and it is giving this reaction. So all you have to do, you have to make the structure, that azo product. Okay, so what part you have used here? OH, yes or no? So at para position you just position this OH. Okay, so this one is called para. OH stands for hydroxy, and then you can write azobenzene, that's the name of this one, and its color is orange, it's an orange dye. Okay, clear? So this is your first coupling reaction. Second one is that if benzene diazonium salt is reacting with toluene, let's say if benzene diazonium salt is reacting with toluene, so what is toluene here? So this CH3, this one is what? Toluene. Again I will draw this benzene diazonium salt, sorry, azo product, azobenzene, and then here the different thing is what? CH3 or not? Yes or no? So we will be writing that CH3 at para position. Okay, so I know that this CH3 is what? Methyl or not? So I will write here para methyl azo benzene. Okay, and its color is yellow, it's a yellow dye. Now basically I have given you the direct way of getting the answer, right? But how this reaction happens, so let me elaborate it with this. Like explanation is only for observation, no need to write it in exam. So this benzene diazonium salt I can write like this, N2Cl as N triple bond N Cl, so this is plus and this is minus, right? And if I arrange toluene in this direction, right, so there is nothing, so I can just assume that there will be hydrogen, because you know that in benzene ring you have always 6 hydrogen, right? 1 hydrogen each at one carbon of the benzene ring, yes or no? So I have just taken this one. So what will do, there will be a reaction between these two portion, okay? And then it gives you this answer. Again I am saying no need to memorize it, just observe it, okay? Like what is the thing happening. The main thing that you will study, it's here, this one. So N2, and then you will get CH3. That's how the reaction happens, okay? So I hope it's clear. Right? So with this we are done with this diazonium salt. Only one small topic is left, okay, that we will do in our next class, that is basicity, okay? But now let's do some question so that it becomes clear to you. Let's say I'm giving you one question. Okay, try this question. So it's an MTG question only. It's question number 95, option B, okay? So what will happen here, like if they give C6H5 NH2 and it's giving you NaNO2 and HCl, right? And then it's reacting with 0 to 5 degrees centigrade, and it's reacting with A, and then it's reacting with C6H5 and H2, okay? And then it's given H plus and is giving you B product, right? So how to solve this? Sweet herbs. Okay, student, there is one correction. This one is not toluene, okay? You have to react this one with aniline. I have made one mistake here, so this one has to be NH2. My mistake. This is not toluene, this is aniline. So here this will be NH2, and here in this case it will be amino. Please correct this one, okay? This is that coupling reaction. The first one that gives orange dye, and the second one is yellow dye, okay? So if I change this one, so it will be NH2, and here it will be NH2, okay? Please correct this one. This explanation part, again I am saying, is only for observation. Okay, now let's move on to this question. So if you draw this structure, right, so I can say that NH2 will be there and C6H5 is benzene ring, right? And then when it reacts with NaNO2 and then HCl at 0 to 5 degrees centigrade, just now we did this one, so it will be N2Cl, right? There is benzene diazonium salt. Now what is the meaning of this one? Can I just write this one as NH2 benzene ring? That means aniline, right? And then H plus. So definitely the second part is coupling reaction. So if it is coupling reaction, then it will give you that yellow color dye just now that we have corrected, right? The mistake one. So N double bond N, and then this is the one, and here you will get NH2. Okay, so it's a yellow dye. Okay, some student might have doubt that do I have to write the name azobenzene and something like that? No, as long as they are not asking, no need to write that. All right, now let's try another question. This is question number 101, option B. Okay, so here they have given NO2. It's a mixture of both amine and diazonium salt reaction. Okay, so it's reacting with FeHCl and it's giving you A, and it's reacting with what? NaNO2 plus HCl, right? And it's giving B. Then they have given C2H5OH and then C. So what will be the answer for this one? So basically this is the first preparation reaction from amine chapter, right? So what will happen if NO2 is reacting with FeHCl, right? The moment it reacts with Fe plus HCl, this NO2 changes to NH2, that is amine structure, right? And then from here onwards is completely diazonium salt, NaNO2 and HCl, right? So that NH2 will change to N2Cl. So this is diazonium salt. And then this one is what I can say, if it's given C2H5OH, right? We can also write this one as CH3CH2OH, yes or no? So that's our ethanol part. Okay, so C2H5OH, and then this is the preparation thing. So what will happen? You will get only benzene ring, yes or no? This is the before coupling reaction. We did some chemical reactions, right? Is that one. All right, let's try another question. This is question number 107, B, option B. So it's given C6H5N2BF4, then NaNO2, Cu is given, and delta, right? And then it's reacting with this, and then after that is reacting with FeHCl, it's B, option B, and then is reacting with CH3COCl, and you have pyridine. Pyridine is catalyst, so you don't have to pay that much attention. The main part is CH3COCl. Okay, let's do this. So here this one will be combination of benzene diazonium salt, then one preparation will be there because FeHCl will you get in preparation part, and then one chemical reaction of amine, that is CH3COCl. CH3COCl is acylation reaction. Okay, I think there's the second chemical reaction of amine. So let's do that. Now before solving this one, change it to normal form. So N2BF4 you will get, and then this one, right? So when it reacts with, this is before coupling reaction. Okay, the reactions that I have given, NaNO2 and then Cu, and heat is given, right? So this NO2 will replace this N2Br. I have explained this, okay, in the chemical reaction part. Then if it reacts with Fe plus HCl, just now we did that, the first preparation reaction, but they have used something else. Yeah, they use the same thing. So here it will change to NH2 and this one, right? And then this one is CH3COCl, that is pyridine in the presence of pyridine. Now this one, what will happen? It will like you know that whenever we use CH3COCl, right? So the part that will be bonded to this product, sorry, this reactant, it's C double bond of CH3, yes or no? This thing we have already discussed in acylation part. Okay, acylation reaction. And what you have to do, you have to replace one hydrogen, and in its place what you have to do, you have to replace one hydrogen, and in its place you have to write this part, right? So it will be NH and then C double bond O CH3, okay, and then it will give you this benzene ring. Yes, in acylation part we did this, okay, the same chemical reaction. Now this same question, this same answer, final answer, you can write it in this form also, CH3 NHCO CH3 and then benzene ring. This here we can just write it in condensed form instead of writing it in expanded form. My suggestion, if they are not asking you, then write this, no problem. But this one I am giving, let's say that the same question they have asked in MCQ form and they are telling us to identify which one is C among the 4 options. So they, instead of giving it in this form, they might give it in this form. So that's why. So this is your A, this is your B, and this is your C. Okay, right, let's try another question. This is question number 106, option A. Okay, so here you have to identify the compound. So NH2 is given, and then here it will be NaNO2 and HCl is there. Okay, and 0 to 5 degrees centigrade. So this is your X and this is your CuCN and this is your Y. Okay, so here also in the solution part, what you will do, you will write NH2, and if it reacts with NaNO2 and HCN, so this one will be N2Cl, right? Again that benzene diazonium salt. Now this one CuCN. Okay, and then one more catalyst was there, KCN, in the main reaction that I have explained. But if they don't give KCN, it's okay, no problem, because CuCN is the main is the main reactant that will react with the reactant. KCN is catalyst. So what's the part? This is Sandmeyer's reaction. Okay, so that Cn is the part or not? So that whole Cn will replace this N2Cl. Sometimes to confuse students, remember that catalyst they might not show also, so don't get confused. If one part is also given of the chemical reaction, and if there is no other options, then directly consider that particular reaction. All right, like these are the questions that were there. Okay, then try one more question. This is question number 88. Okay, so in question number 88, we are mainly focusing on the questions from benzene diazonium salt, and then it's reacting with NaNO2 HCl, and it's giving X, and then C2H5OH is there, and it's giving Y. So what will be the answer of? They've given that it's an MCQ question. What is the structure of Y? Okay, so why they are asking this one? So they have given 4 options. The first option is this one, second option is this benzene ring, third option is benzene ring and NH2, and fourth option is this benzene ring and N2Cl. Okay, so what will be the solution part? So in solution part, NH2 is there and it's reacting with NaNO2 and HCl, right? So this one will be N2Cl. Now again, what is this C2H5OH? What is this C2H5OH? We have just now explained, right? Like few questions back, is nothing but CH3 CH2OH. Yes or no? So this whole N2Cl will be removed and you will only have benzene ring. Yes or no? So your option will be this one. Okay, now yeah, most of the questions are done from that were given in your MTG book based on benzene diazonium salt. Okay, let's try another question. Last question is there. So with this, all the varieties, all the questions of diazonium salt will be over. Question number 92 MTG. Okay, so they have given C6H5N2Cl and it's reacting with CuCN A, and then it is reacting with H2O and H plus. It's B. Okay, this one is actually carboxylic acid reaction, okay, like second part. So in this second part I'll just do the, like I will explain you the stuff. So if it's what do you call it, let's say this is, let's write it as node point. So if it is RCN, okay, and if it undergoes hydrolysis H2O and H plus, so first it changes to RC double bond ONH2, okay, and then it will continue. Means here if they mention the word partial, okay, so you will just stop it here, but if they don't mention the word partial, it will continue, and again acidification will happen, and this whole CONH2 part, it will change to RCOOH. Like, to make it more simple, you can just remember it like this. If they just give you RCN and then they just mention H2O and H plus, okay, directly change to carboxylic acid, okay. And if RCN is mentioned and they have mentioned this H2O and they have used some words which is indicating that it's going half reaction or partial reaction, so this one will change to RCONH2, that amide. But since they have not mentioned here any partial thing, so I'll be using the first reaction. So this is from preparation of carboxylic acid, okay, you can refer that, it's given there. So now how we will do the solution. So let's say it's N2Cl and this is the benzene ring, and it's reacting with CuCN. So obviously this Cn part, again this is Sandmeyer reaction, so this Cn will replace this N2Cl. Now if it's hydrolysis happening H2 and H plus, right, so what will happen, this Cn, since partial is not used, so I'll be using this one, right, yes or no, the first one. So this Cn will change to COOH, and that's our final answer, okay, got it. So that is our A and our B, okay. Alright student, so with this we're done with the benzene diazenyl salt part. One more small topic is left, that is basicity of amine, so we'll do it in our next class. So thank you class.